Welcome you all to the Research Spark YouTube channel. So now we are going to talk about the fourth unit in this course, that is the transmission line theory and introduction to interference as well. So here's the syllabus. Basically, there are two parts of this unit fourth. First is the transmission line, that is the equivalent circuit and characteristic, and second part is the the interference, that is the electromagnetic interference. So first let's talk about the transmission line parameters and about the transmission line exactly. So first, what do you mean by the term transmission line? So very simple, like we are considering the one of the example of the transmission line which can be used to transmit the energy from source to destination, that is a transmission line. So mostly you are the observing in your daily life the transmission line which is being used to transmit the energy in terms of the electric energy, like voltage that may carry the 33,000 of voltage. So that one is the one of the example of the transmission line. So our objective is that how to find the wave, that is how the wave will propagate in terms of the electrical parameters. So how voltage will propagate in the transmission line, how current will propagate in the transmission line. So this is our objective. So in the previously we have discussed how the electric and magnetic field is propagating. Now in this transmission line parameters we are just replacing that with the voltage and the current. So let's try to find, that is how voltage wave, how current wave will propagate in the transmission line. So first, since these are the electrical parameters, so let's find out the equivalent circuit first using for this transmission line. So how can we draw the equivalent electrical circuit? So of course, electrical circuits means the parameters are the R, L, G, C, that is resistance per unit length, inductance, and then conductance. G is your conductance, that is 1 by R only, then the capacitance. So let's described in all these parameters. So for each line, the conductors are characterized by the mu, sigma, mu, epsilon naught, all these homogeneous dielectric separating by conductors. So one of the conditions like LC is equal to mu E or G by C is equal to sigma by E. These are the basic things that you should remember. So and also the the different types of the transmission lines. Here are the example like coaxial line, then the two wire line, and then the planar line. So for these different examples, let me try to see. So if you wanted to draw the equivalent circuit, uh, the trans of the type of the transmission line is coaxial line, then resistance will be like this one, inductance will be this, and the conductance and the capacitance similarly. For two wire you can find out RLGC, for planar line you can find out RLGC. Means in this manner, if you have the transmission line of coaxial line to a wire or planar one, you can find out the equivalent values of the resistance, inductance, conductance, and capacitance. So once you will get these RLGC values, then you can draw the circuits very easily for the any transmission line. So as for example here, let's actually we are going to draw this particular type of the the circuits. So for the two conductors transmission line, suppose this is your coaxial two conductors and planar. So this is your two conductor parallel lines. Suppose the dimensions, that is the diameter is 2a and the separation in between the two conductor is d. So this is the separation, that is d, and then these are the diameter having the 2a. So these are the two conductors. So this is the example of the two conductors parallel lines. So how can we draw the equivalent circuit? So electrical equivalent circuits may be the resistance, inductance, and then again resistance, inductance. So these are in series, and in parallel conductance and the capacitance, again parallel conductance, capacitance. So this is the equivalent circuit for the two wire conductors. Now, similarly, you can redraw these equivalent circuits to find out the values of the voltage at any transmission line on this and the current. So here resistance, inductance, and then the conductance and capacitance. So since I z, that is I naught is suppose the length is entire length is z. So let's find out z plus z. So for a small t, so here the suppose v is v z plus z del t del z and del t, and your I is at I z plus z. So actually suppose the length is z, but we are going to consider for a small d del z. So that's why current at z plus del z, voltage at z plus del z, and this is the voltage and current at z. So using the KVL, you can write this one voltage plus this one voltage is equal to voltage drop at is at resistance at inductance plus this one. So this is that particular. Similarly, you can write the KCL. Using the KCL, we can write the current equations at this particular node, that is the current which is passing coming at this point, which will be divided into the this and this one. So that is Iz is equal to del I plus Iz plus del Z. So once you will characterize the using the KCL, that is the Iz plus the Iz plus del Z and plus del I, then replace the value of I Z plus del Z using the conductance and the capacitance, then you will get. And similarly di, you will get the values of the di by dz using, just take it in the left side, and then you will get. And so finally using the KVL, you will get dv by dz, that will be equal to this one. By replacing these values, v is equal to our real part, that we are just considering the real part values, and I is equal to our real part I is to the power j. Just replace these values. S is equal to j omega, replace S is equal to j omega, and then you will get these values. Now take the differentiation of particular this equation, and then you will get the double derivative and replace the value of del I by dz. So take the double derivation and replace these values, you will get this. So this is nothing now the normal second order derivative equation. So where gamma square is equal to what? This one will be the value of the gamma square. This one means r plus j omega l plus g into j omega c. So gamma is this one, and also the gamma is nothing alpha plus j beta. So now further you can find out the values of alpha and beta. So this is the most important result. So you must have to remember this one, that is value of the gamma. So what is the value of gamma? Square root of r plus j omega l into the j plus g plus j omega c. So in that manner we got the value of gamma. Once we got the value of gamma, that is propagation constant, it is very easy to solve. Also your Z naught, that is impedance, can be written as something like that. Here it can be written as r plus j omega l by gamma, or gamma divided by j omega g plus j omega c. Also Z naught is can be written as r plus j omega l divided by g plus j omega c. This is one of the important results, and Z naught will be r naught plus jx naught in the real parts and imaginary parts. So apart from the value of gamma, Z naught is one of the key important parameters. So now if you remember both the values, now it's very easy to characterize the different mediums. So suppose the medium, that is transmission line, is lossless, that is R is equal to Z is equal to 0. In that case, your alpha will be 0, and gamma, your beta will be your omega square root of LC, and then Z naught will be a square root of L by C. So how will you get? Very simple, values of from the gamma. So just if you remember the value of gamma, then it's very easy to find out the values of alpha and beta. Similarly, for distortionless line, your condition is R by L is equal to G by C. So use these equations and get the values of gamma. So here alpha and beta will be the these values, just equate from the gamma equations, and then you will similarly Z naught you will get the values square root of R by G and L by C. So general, this is a very general, this is the major parameters that you should remember. Generally your gamma will be this one, and for lossless alpha is 0 and beta is this, so the your gamma. For distortionless alpha and beta both are same only. No, alpha is a square root of Rg and gamma beta is square root of omega L square root of Lc, and Z naught you can see. So these are the key parameters. If you remember these values, then you can solve any equations, any the questions related to the transmission line. So that's all in this session. So we'll talk about the EMI, EMC in the next sessions. Thank you for listening. If you have any problem, please drop your comments. Thank you.